Hello everyone, hope you guys are doing well. So in this video we are going to be solving a past paper of May 2021, paper 1 variant 2. So this is, as of now, this is the last summer paper. Yeah, so here is question number 1, part A, which says write 0.45 as a fraction in its lowest term. So that's usually how the paper starts. It starts off with some very simple arithmetic questions. You can expect fractions, you can expect decimals, you can expect percentages, some simple BODMAS. Who knows, we might come across such questions, but that's how the question usually, that's how the paper usually starts. Okay, so first things first, 0.45, you want to write it as a fraction and it's for lowest terms. So you want to see how many decimal places there are. So you can see that there are 2 decimal places, which means that you'll multiply it by 100. And since you've multiplied it by a certain value, that means now you got to divide it by the same value also. So you're looking at 45 over 100. Which if you simplify, you can simplify using the table of 5, okay? So 5 9s are 45, 5 2s are 10, 0 as it is, and that means now you're looking at 9 upon 20, and that's your final answer. That's one free mark that's in the bag. Now moving on. Okay, now one thing I should mention is when the question says that you have to write your answer in its lowest terms, then there's no getting away from it. You have to give your answer in its lowest terms. That's it, okay? You can't expect to leave it as 45 over 100 and expect to get the same amount of marks or expect to get that 1 mark, because that's not what the question said. Okay, so now we have part B, which says write these fractions in order of size starting with the smallest. So one thing, first let's have a look at the fractions that we have here. So we have 4 upon 5, 7 upon 10 and 17 upon 20. So one thing that I always tell my students is not to have like a standard approach towards these questions. Okay, so what I normally do is I convert them into decimals and then arrange them and then give the final answer. So that's obviously recommended, not discarding that. But over here I'm not going to do that, because if I look at the denominators over here, so I have 5, 10 and 20. So what I would rather do is I would rather make sure that all my denominators are the same, and since 20 is basically a multiple of 10 and a multiple of 5, so that's what I would prefer, that I turn all my denominators to 20. Okay, so that's obviously going to require a bit of math. That's what we're here for. So we're going to multiply 5 by 4, that means we're going to multiply 4 by 4 also. So we're looking at 16 upon 20, we're going to multiply 10 by 2 and 7 by 2 also. So we're looking at 14 upon 20, and then 17 upon 20, we're going to do nothing to it at all because the denominator is already 20. Okay, once you've done that, then it's a whole lot easier for you to compare, okay, because the denominators are the same. So you can see that 14 over 20 is the smallest value, so I'll just put a small 1 here. But whenever you're writing a final answer, remember to write it the way it was given to you in its original manner. And then you have 16 upon 20, so that's number 2, so that means now you have 4 upon 5, and then you have 17 upon 20. There you go, and that's your final answer, and that's also the correct answer. Okay, then we move to number 2, and let's see what it says. So it says complete the description for the symmetry for each shape. Okay, so we're dealing with a question that's related to symmetry. Haven't encountered symmetry in a while, but yeah, anyway. So it says here, you have 2 shapes. The question's asking you to write down the lines of symmetry and the rotational symmetry of order. So first things first, as far as lines of symmetry is concerned, so always be open to the idea of scribbling, doing a bit of trial and error. Whatever you do it with a pencil. So if you look at this shape over here, so you have this as one line of symmetry, okay, and this also as one line of symmetry, and this also as one line of symmetry. I have a video made on symmetry. No, wait, I don't have a video made on symmetry. I have a video made on rotational symmetry, so I'll leave a link to it. You guys can check it out. Okay, so had this been a regular hexagon, which means a 6-sided shape, then this shape would have had 6 lines of symmetry and also 6 as its rotational symmetry of order. But since it's not it is a regular hexagon, but you have 3 shaded triangles in it, so that means now things are slightly different, and you can see that now it has just 3 lines of symmetry. Okay, and as far as rotational symmetry goes, the order of rotational symmetry will also be 3, because if you rotate it 120 degrees, okay, these triangles will just sort of take place of each other, and over a period of 360 degrees, all of this will happen 3 times, so that means the rotational symmetry of order is equal to 3. Now we come to the next figure that we have here, and in it, first things first, you need to write down the lines of symmetry. Now, I think not all, but some students, I'm afraid, will fall for the trap, and they would say that this is the line of symmetry. Okay, and I hope you, whoever whoever is watching wasn't thinking the same, but even if you were, that's fine, okay? The reason why you shouldn't fall for this trap is because in symmetry, one way to quickly identify whether this is a line of symmetry or not is basically by imagining what would happen if you were to take this triangle, okay, and reflect it along the line that you think is a line of symmetry, okay? So if you were to do that, you would know that this is where this will end up, okay? That's how reflection works. Same distance across the line of symmetry, whatever you think as is your line of symmetry. But that's not what the case over here is, okay? So that means this is not going to be your line of symmetry, okay? Let's see if we can come across with any other line of symmetry. Sadly, we cannot. So straight away, our answer is 0 as our line of symmetry. Now, as far as rotational symmetry of order goes, I mean the order of rotational symmetry goes, if let's say I rotate this 100 and 180 degrees, so you would barely notice that this shape has been rotated because every shaded region will take place of the shaded region or the other shaded region, okay, and you would barely even notice that the shape has been rotated. And this, if you were to give it another half turn, meaning if you were to rotate it 180 degrees, exactly the same thing would happen. So that means in 360 degrees this happened a total of 2 times, so therefore we say that this shape has rotational symmetry of order 2. There you go. Okay, now we're on question number 3. Now we're doing question number 3. So let's see what it says. It says a group of 60 students were each asked their favorite fruit. The results are shown in the table. Complete the pie chart to show the results. Okay, so we can't really make the pie chart because I don't have the appropriate tools since I'm doing this on a tablet. But I will tell you how it works. Okay, so apple has already been drawn for you, and you're asked to complete it. So let's see how exactly they made this pie chart up until now. So this pie chart was basically made by first of all calculating the total number of students. So you can either work it out or you can read the question. It says 60 and we have the total number of students. So if I want the basically the piece of the pie that apples would take, so I can work it out by taking 20 upon 60 and multiplying it by 360. So what do I get? Let's see, 1/3. So basically 20 upon 60 is 1 over 3. 1/3 of 360 is 120 degrees. So that basically means that this is 120 degrees. Okay, and just like that we'd work out for bananas also. So we do 25 upon 60, since that's what the total is, and times it by 360. So 25 over 60, well, let's not let's just do it the way it's meant to be. So 25 times 6, so 25 times 4 is 100, 25 times 2 is 50, so 100 plus 50 is 150 degrees. Okay, and similarly if you want to work it out for this, for oranges, so you do 15 upon 60 and then multiply it by 360. So 15 ones are 15, 15 fours are 360, so that means you're getting 90 degrees. And just to be sure whether we've done it correctly or not, what I would like to do is I'd like to sum them up and see if I'm getting 360. So 120 plus 150 is 270, 270 plus 90 is indeed equal to 360, so that means I'm sure that I've done it correctly. Okay, so now comes plotting, the plotting part. So if you want to plot 150 degrees, I will tell you how it's done. So what you do is you put your protractor over here. So imagining that this is your protractor. I know this is a hideous way of showing it, but I'll get the job done. So this is going to be 90 degrees. 150 degrees, since it's an obtuse angle, has to be somewhere over here. In fact, it's, it's going to be over here. It's going to be exactly like this because the other angle is 90 degrees. Okay, so that's cheeky, but yeah. Gets the job done. So this angle that you're looking at is 150 degrees. There you go. And this angle that you're looking at is 90 degrees. So don't forget to label it. This is for bananas, or bananas, whatever you want to call it. This is for oranges. Okay, so singular, not plural. But anyway, orange and banana. Okay, there you go. That was that. Now we come to question number 4, which says write 64. Okay, so you know what? I'm going to read it as a number. First, I'll just read out the digits. So 647854491, correct to the nearest million. Okay, so this number is actually 64,785,491. Okay, so that means it's 64 million something, right? Okay, so 64,785,491. Okay, so it's between 2 millions. So one of them is 64 million. Okay, and the other is 65 million. Okay, so that's sorted out. Now 785,000 means that it is beyond the halfway mark. So that means it's closer to 65 million than it is to 64 million. So that means if I were to round this number correct to the nearest million, I would have to settle for 65 million. So I'll write 65 and then 6 zeros. So remember, million has 6 zeros, 1000 has 3, million has 6, and billion has 9, and trillion has 4. Okay, yeah. Then it says, by writing each number correct to one significant figure, estimate the value of. Okay, so writing every number correct to one significant figure. So let's start with 67.8. So this would either be 60 or 70, but since it's closer to 670, therefore we'll have to lock it at 70. 49.5 would either be 40 or 50. So, 50 it is. 0.187 whole squared could either be 0.1 or 0.2, but since it's closer to 0.2, or you can say since the decimal value after 1 is greater than 5, so it has to be 0.2. So 70 plus 50 is 120. 0.2 squared, okay, 0.2 squared, I'd bet, not all of you, but some of you thought that 0.2 squared is 0.4, okay? But it's not, okay? 0.2 squared is not 0.4. In fact, I posted this on my Instagram a couple of months ago, and I was surprised to see how so many people answered that 0.2 squared is 0.4. It is not. Why? Because you're doing 0.2 times 0.2, and if you do 2 times 2, so that's 4, and you have total of 2 decimal places. So that means you'd move the decimal 2 places backwards. So that's 0.04. And then, of course, at this point, don't forget to convert this into integers so that you can work out the actual value. So you have 12,000, over 4. So 4 ones are, 4 threes are, and then you have 3,000 as your final answer, which is the correct answer. Okay. Then it says Umar and Jamil share $540 in the ratio 7:2. Work out Umar's share. So that should be pretty simple. So Umar is getting 7 parts from a total of 9, and if you're wondering how I worked that out, I simply added 7 and 2 and multiply this by 540 to find out the actual amount. So 9 ones are 9, 9 6 are 54 and 0. So 7 times 6. 6 times 7 is 42. Yeah, so $420, and there you go, that's the correct answer. So now in part B, it says increase 40 in the ratio of 5/8. Okay, so there's a small catch in this question. It's asking you to increase a certain value, but if you were to multiply 40 by 5/8, okay, so what you would end up with, what you would end up doing is you'd end up decreasing the number, okay? So if you want to increase a number in a certain ratio, so always put the larger value at the top. So that means you'd put 8 upon 5 so that the result is the increased value. Okay, so now you can work this out. 5 ones are 5, 5 eights are 40. Is it? Yeah, 8 times 8 is 64, and there you go, that's your final answer. Okay, so pretty simple so far. Okay, now you have a question that's related to nets. Again, something you have to be very careful and do it step by step so that you don't end up getting anything wrong. It says the base of a cuboid is a square with side length 4 centimeter. All right, the volume of the cuboid is 48 centimeter cube. Okay. On the grid, complete the accurate drawing of the net of the cuboid. Okay, the base is drawn for you. All right, so if I look at the base, I can see that the base of the cuboid is basically a square of length 4 by 4. So, and I'm given the volume, okay? So, volume of any cuboid is basically length times width times height. So, we know that the volume is 48 and the length is 4 and so is the width. Height, however, is unknown, okay? So, 4 times 4 is 16. So, 16h is equals to 48, and now if I make h the subject, so I'm looking at let me write this correctly. So I'm looking at 48 upon 16, which means height is equals to 3. And now that you have the height, this basically solves, not the entire question, but yeah. So we kind of have an idea of what we're dealing with. Okay. So now if you want to make a net, so let's take a step back and see what a cube looks like. Okay. So a cube basically has 6 faces. Okay. You can grab a cube if you want, or better yet, let me show you on the application that I have on my iPad. Okay, so I want you to ignore what it says quadrangular prism, okay? This is a fancy term of a square-based cube, okay? But this is what a cube looks like, okay? You can see that it has a total of 6 faces, 1 at the top, 1 at the bottom, and 4 at the side. And if you open it up, okay, this is something that I always find extremely satisfying to watch. This is what it looks like. So this is one way through which you can make a net of a cuboid. And there are other ways through which you can also, I'm saying this just so that you guys know that there's not just one correct answer. It depends on the grid that's provided to you, according to which we're going to mold our answer. Okay, so you can see that you have a square over here, okay? You can see that you have a rectangle over here and here, here and here, and then you have another square. In fact, you know what? I'm going to color the squares green. Yeah. So one green square is representing the base, the other green square is representing the top. And if I were to fold this again, this would probably make a whole lot sense to you. that you have a square at the top, a square at the bottom, and the height, so height basically in this case is this, which we just found out to be equal to 3. Okay, so now we go back to our question, okay, to the real world, and this is what we have. Okay, so now we gotta make our shape accordingly, and you know, we have to see what the dimensions are and then complete the shape. So the base, this is the base. Let's say I consider this to be my base. Okay, so I know there's one flap that's going to be on the left side of the base and one flap that's going to be on the right side of it. And these flaps that I'm talking about are going to be rectangles with dimensions 4 by 3. Okay, so there you go, 4 by 3. Here's one rectangle, and then here's another. So let me just fix this real quick. Oops. There you go. Okay, and just like this, you'll have one flap that's at the, you can say at the back side of the base, okay, and one that's going to be at the front. Okay, that's what you want to call it. Okay. Now at this point, if I stop and count the number of faces, so I can see that I have 5 faces. One face is still left, and that is basically the top, okay, which is going to be the same as the base. So the top side is going to be a square of 4 by 4, and there you go. Okay, so I'll label this the top, and there you go. That's it. Now you have scored all 3 marks for it, and this is the final and the correct answer. Okay, now moving on to the next question, which is question number 7. Let's see what question number 7 says. Okay, so question number 7 says a bag contains colored counters. A counter is taken from the bag at random. The table shows the probabilities of taking a counter of each color. So you're given the color and you're given the probability. Okay, and what is the question asking for? The question is asking for you to complete the table. Okay, so probability, as we know from prior knowledge, as we should know from prior knowledge, that the sum of probability or the total probability of any thing is equal to 1. Okay, so we have the probability of 3 out of 4 events, so we can work out the probability of the 4th event. So all we got to do is we got to sum this up. So 0.15 plus 0.30 plus 0.42. Let's see what this is. So 5 plus 0 plus 2 is 7. 4 plus 3 is 7. 7 plus 1 is 8. So I'm looking at 0.87. And if I subtract 0.87 from 1, so I'm looking at 0.13. Yeah, that's what we're looking at. And there you go. That's your final answer. Then it says work out 3 whole 2 upon 5 minus 1 whole 3 upon 4. Well, we can do this. 5 times, so first things first, we got to convert this into an improper fraction. So 5 times 3 is 15. 15 plus 2 is 17. So 17 upon 5 minus 4 times 1 is 4. 4 plus 3 is 7. So 7 upon 4. So we can't work this out. We have to first take out the LCM, which is going to be 20. We're going to multiply 5 by 4 and then 17 by 4 also. So that's 34, 68. Yeah, 68 minus this by 5, this by 5. So that's 35. Now 68 minus 35, if I'm not wrong, is 33. So we're looking at 33 upon 20. So you can stop here if you want, and even if you write this as a mixed number, then that will also score you the same amount of marks. So 21s are 20. I'll just do it so that you know what I'm talking about. And the remainder is 13. So how do you write a mixed number? Quotient, remainder over divisor. So quotient is 1, remainder is 3, divisor is 20. So that means I'm looking at 1 whole 13 upon 20. And that's that. Now we come to question number 9, which I'm afraid we will have to skip. I'll make a separate video on it where I have a different setup where I can just show you my compass and protractor. And yeah, so sorry about that. Okay, so now we come to question number 10, which is a fairly simple question. It's asking you to write 270 as a product of its prime factors. So again, something that's fairly simple. So we start with 270 over here. We start dividing it by the smallest prime number, which, since it's an even number, has to be 2. So 2 times 135, and then 135 is a multiple of 3, so we're going to go with 3. So 3 times 4 is 12, 1 carried, and 45. And then we can divide by 3 again, so 3 times 15, and then we can divide by 3 again, so 3 times 5. And then finally we divide by 5, and we keep on doing this till we get 1. So that means we're looking at 2 times 3, well, if you wish, you can write it as 3 cubed times 5. In fact, I will suggest you write it as 3 cubed so that, you know, you save some space. And then it says find the highest common factor, which is the HCF of 270 and 225. So the good thing is the question has already made us write 270 as a product of its prime factors, which is 2 times 3 cubed times 5. Now we can write 225 as a product of its prime factors. Okay, so we start dividing 225 by 3. actually, you know what, you can also divide by 5. I think that'll be a lot easier, because 5 times 25, in fact, you know what, let's just go with 3. Okay, so 3 7s are 21, and then you carry the 1, so 3 5s are 15, so you have 75, and then you have 3 again, so 3 times 15, yeah, no, wait a minute, 3 times 25, okay, 3 times 25, and then you have 5 again, not again, but yeah, you have 5, so 5 5s are 25, and then you have 5 again, so 5 1s are 5, so that means 225 is basically 3 squared times 5 squared. Now when you're finding out the HCF, so what you're looking for is whatever is common between the two. So if I look at 270, I can see that there's a 2 there, but if I look at the powers of 3, so you have 3 cubed and 3 squared, and what's common in these two? Well, 3 squared is what's common, and then you have 5 and 5 squared, so what's common here? So that's 5, that's common, so that means the highest common factor can be worked out by working out 9 times 5, which is equal to 45. Okay, so just to explain this again, whenever you're finding out the highest common factor, you're basically looking for the maximum amount of factors that are common. Okay, so that's what highest common factor is. Okay, so 2 is not common, it's only in 270, it's not in 225. You have 3 cubed in 270 and you have 3 squared in 225, so that means 3 squared is something that's common in both of them, and you have 5 in 270 and 5 squared in 225, which means 5 to the power 1 is common in both. Okay, so that's part B. Then we have question number 11, in which you're supposed to solve the two equations simultaneously, one of my absolute favorite, and the method that I'm going to use is elimination, because the equations are just pretty simple and you don't have to use substitution. I mean, you'll get the right answer, but I would prefer and use elimination. So I'll take the first equation multiplied by 3. I'll take the second equation multiplied by 2. I have made videos on simultaneous equation. If I haven't forgotten, I'll leave a link to it in the description. Otherwise, you can always check it out on my channel. So if I multiply the first equation by 3, so I'm looking at 15x plus 6y is equals to 21. And if I multiply the second equation by 2, so I'm looking at 4x minus 6y is equals to 18 times 2 is 36. Okay. Now if I add the two equations, I'm looking at 19x plus 6y minus 6y gets eliminated, which is not a coincidence. This is exactly what we wanted. 21 plus 36 is basically equal to 57. So x is equals to 57 divided by 19. And with a bit of mental maths, you'll be able to find out that that's equal to 3. Once you have the value of x, don't get carried away. You still have to find out the value of y. So 5x plus 2y is equals to 7. In place of x, we plug in 3. So 5 times 3 plus 2y is equals to 7, which means 15. Plus 2y is equals to 7, which basically means that 2y is equals to 7 minus 15, which is minus 8, and y is equals to minus 4, and there you go. The value of y is minus 4, which is the correct answer. Okay. Now we have question number 2, which says Laura goes for a cycle ride. The distance time graph shows her journey. So this is travel graphs, yeah. Calculate Laura's average speed in kilometers per hour for the whole journey. Okay, so average speed is something that can be worked out very easily. So all you got to do is you got to find out the total distance that she's traveling, okay, and divide it by the total time that she's taken. All right, and we can do that. We can do both by looking at the graph. So total distance shows, so she's going from 0 to 24 here. Okay, so for a second I was gonna say 25, but got to be careful there. So 24 is the total distance, and the total time, well, she starts at 10 o'clock and travels till 11:30, so that means that's 1.5 hours or 1.5 hours. Now this, in order to work it out, I'd suggest you multiply the numerator and the denominator by 10, so that you're not dealing with any decimals. So you're looking at 240 upon 15. Let's start simplifying this by 5. So 5 3s are 5 4s are 20, 4 carry, and then you have 8, 5 8s are 40, so 48 upon 3, which is equal to 16. That means her speed is 16 kilometers per hour, which is the correct answer. Okay, then it says a car travels at a constant speed of 10 meters per second for 80 seconds. It then decelerates at a constant rate of 0.5 meter per second square until it stops. On the grid, draw the speed time graph for this journey. Okay, so this shouldn't be that big of a problem for us, but let's see. So let me see. Travels at a constant speed of 10 meters per second for 80 seconds. So constant speed on a speed time graph is shown by a a straight line. Now, if I just say a straight line, that's not enough, okay? Every line is straight. That's something I always tell my students, and that's something that always blows their mind. Every line is straight, but you got to be able to narrow it down and say, okay, it's a horizontal line, okay? So 10 for 80 meters per second, for 80 seconds, 10 meters per second for 80 seconds, so that means you're going to get a horizontal line at 10 for 80 seconds, okay? It then decelerates at a constant rate of 0.5 meter per second square until it stops. Okay, so for this, there's a bit of working that's required. If you can work it out mentally, that it's going to take, since it's decreasing its speed by 0.5 meters per second every second, that means it's going to take 20 seconds to come to a complete rest. If that's something you can work it out mentally, that's fine. That's great. If that's something you can't work it out mentally, that doesn't mean that you're an absolute idiot. Okay, that's not what it means. You can always do a bit of math and work it out. Okay, so deceleration basically means that acceleration is negative, which is minus 0.5, and something you should know from prior knowledge is that acceleration is basically the rate of change of speed. Okay, so if it's coming to a rest, which basically means if it's coming to a stop, so that means there will come a point that its speed is going to be equal to 0. So what that basically means is that we're looking at a line which at some point is going to come at rest. Okay, we don't know what point that is, but what that basically means is that the value of x is unknown, but the y value for sure is 0. Okay, so that means one point on the line we know is t comma 0, and the other point is this point, which is 8t comma 10, and the gradient of the line that's passing through these 2 points is minus 0.5. So if I want to work out the gradient, so I'll do 10 minus 0, which is y2 minus y1, over 80 minus t is equals to minus 1 over 2. Okay, I've converted this into fractions so that it's easy for me to work with it. So if I cross multiply, so I'm looking at 20 is equals to minus 80 plus t. T is equals to 20 plus 80, which means t is equals to 100 seconds. And there you go. Now you know that this line will touch the x-axis when t is equals to 100, and now you know exactly how to complete your graph. Okay, so now we have question number 13, which says write 0.00053 in standard form. Okay, so a question related to standard form shouldn't be that big of a problem. So over here we have to move the decimal forward, so 1, 2, 3, 4, 5, and why stop here? Because this is the point where the value will be 5.3 and it's going to be between 1 and 10. So we're looking at 5.3 multiplied by, and how many places did I move it forwards? I forgot. Okay, so let's just do that again. Okay, so 1, 2, 3, 4, 5. Let me double check. 1, 2, 3, 4. 1, 2, 3. Sorry about that. Let's just do it one more time. 1, 2, 3, 4, 5. Yeah, so 5 places forwards, which means that the power is going to be minus 5, and there you go. That's your final answer. 5.3 into 10 raised to the power minus 5, which is the correct answer. Great. Okay, now evaluate. So you have a number which is in standard form being multiplied by another number which is also in standard form. So for this, just remember apples with apples and oranges with oranges. Okay, something, if you've been following my videos, so something that you've heard over and over again. So 1.5 times 8 basically means that you're multiplying the apple in the first number with the apple in the second number, and 10.4 to 10 to the power 14 multiplied by 10 to the power 6 is basically the orange that I referred to earlier. So 1.5 times 8, if that's something you can work out mentally, I'll give you a simple trick to work it out. So what you do is, whenever you're multiplying a number by 1.5 or 1.5, so what you do is you multiply it by 1 first, so 8 times 1 is 8, and then you multiply it by 0.5, so 8 times 0.5 is 4, and then you add the 2. Okay, so 8 plus 4 is equals to 12. But again, something, see, shortcuts are something, if you get the hang of it, that's great. If you don't get the hang of it, there is always the conventional way which you shouldn't be shy of using. Okay, so if I want to do 8 by 1.5, so I'll do 15 by 8, okay, ignoring the decimal, the way that we multiply decimals. So you'll notice that you get 120, but since you were supposed to do 15 or 1.5 by 8, so that means you'll move the decimal one place backwards, and that way you end up with 12. Multiplied by 10 to the power 4, 14 multiplied by 10 to the power 6 basically means that you will add the power, so you're looking at 10 to the power 20. Now, the problem with this is not in standard form because 12 is greater than 10, so I'll move the decimal one place backwards, and whenever you move the power backwards, you increase, whenever you move the decimal backwards, you increase the power by 1. So that means now you're looking at 1.2 into 10 to the power 21 as your final answer. Okay, so let's do question number 14, see what it says. It says the length of a path is measured as 62 meters, correct to the nearest meter, so that's very important. Nearest meter means 1 meter, so I'm going to divide by 2, which is 0.5. And if I want the upper bound, I will add 0.5, so that means that's 62.5. If I want the lower bound, I will minus 0.5, so that means 61.5. So 62.5 is going to be my answer because the question has asked for the upper bound, and that is the correct answer. Okay, then it says the mass of a bag of peanuts is 80 grams, correct to the nearest 10 grams. So at this point, you know what? Here's what I would suggest. Don't read what the question is asking further, okay? Immediately first work out what the upper bound and lower bound is going to be, okay? So nearest 10 grams mean I'll divide 10 by 2, which is equal to 5, and I'll add 5 and 80, so I'm looking at 85, and I'll subtract 5 from 80, so I'm looking at 75 grams. So I have the upper bound and the lower bound. Now, obviously the question will have to do something with the upper bound and the lower bound, so that's why I didn't bother reading what the question said later on. I worked it out immediately. Now I'm going to read what the question says and see how we can work it out. Calculate the lower bound for the mass of 5 of these bag of peanuts. The lower bound is what we're focused on. So we'll do 5 times 75, which is 225, is it? Well, just to be on the safe side, let's do 75 times 5, so that's 25. 7 times 5 is 35, 35 plus 2 is, 375, sorry, my bad. Good thing that I multiplied. See, that's the thing with shortcuts, okay? So it's always a good idea to do it the conventional way and then check your answer. Anyway. So that's all for this part. For the remaining questions, I'll make a separate video. So yeah, see you guys in the next video. Until then, take care. Bye-bye.